Hello, everyone. My name is Terefe, and I was a remote fellow at Museum Conservation Institute from November 2020 to November 2021. And my research was to investigate reality technology and how it could be used for research and conservation by combining it with scientific and computational imaging for dynamic visualization. So when we usually talk about reality technology, we usually refer to virtual reality, augmented reality, and mixed reality. But for this research, we only focus on the first two, VR and AR. So if we look closely at VR, there are four four displays. The first one is a head-mounted display, also known as HMD. The second one is a cave automatic virtual environment, or simply known as cave. This is where the user is in a room and digital projection are projected on the walls, ceiling, and floor. The third display is large monitors with 3D stereoscopic glasses. And the last one is just your regular monitors. Each of these displays correspond to different immersion levels. The first two, HMD and Cave, are fully immersive, meaning that the user's environment are fully replaced by digital environment. The large monitor with 3D glasses are semi-immersive, and your regular monitors are non-immersive. So if we compare the non-immersive versus the fully immersive VR experience, the non-immersive doesn't require any additional gadgets such as an HMD, but that does not provide a sense of presence for users, and that could impact information retention. Whereas in a fully immersive environment, people could retain more information, but that comes with a downside that it can negatively impact their health with simulation or cyber sickness. But if we look at augmented reality, the technology is slightly different than VR, meaning that instead of cutting the user from their environment, this time it overlays digital information on the user's environment. And that would allow users to have more information about the surrounding. And there are two displays for this. The first one is a tablet, and the second one is a smartphone. Now, if we compare AR and VR, and by VR, we mean fully immersive environment. In VR, it replaces reality. So the user's reality is replaced by a digital environment, whereas in augmented reality, it adds to their reality. So in VR, they're completely disconnected. In AR, they combine the digital and the real environment. But in both cases, it allows dynamic visualization. Now that we have a grasp on what reality technology is, let's look at it from a cultural heritage perspective. Usually there are four common ways that they're used. The first one is reconstruction, and that is to rebuild a site that is no longer in existence, or the site that doesn't look what it looked like in the past. Edutainment, it's a gamification, meaning it is allowing the user to build their own experiences like in a video game and to learn about a historical site or event. Virtual museums, there's an example here, picture on the right, and that's from the Smithsonian American Art Museum. It's called Beyond the Walls, is where users can experience the exhibition from the comfort of their home by using fully immersive VR. The last one is exhibit enhancement. And for that, it's when the users are actually in a museum setting, they can use their tablet or smartphone and look at objects or artifacts, and they will get more information displayed on their phone or tablet about that specific object that is not available without the AR or the application. So if we look at this is a chart sort of explaining about the different ways that they are used in a museum, and they're breakdown in different sections. So the first one is education, second is exhibition, exploration, reconstruction, and virtual museums. And if you look at it closely, we can see that exhibition is mostly used for reality technology, and AR is the preferred method. The second one that's most commonly used is for reconstruction, and once again, AR is the preferred technology. And lastly, virtual museums is the third most used, and they prefer VR for fully immersive environment. So most of these show that they're catered towards like allowing people to experience the cultural setting with these technologies, so to enhance their experiences. But there are also a few examples that do something completely different, meaning they focus on research. And here are two different examples that use reality technology for research and conservation. The first one is an AR app that helps curators find the best place to set these artifacts so that they don't fall and break. The second one is for marine archaeology, and marine archaeologists can only be submerged underwater for a short period of time. But with this VR app, they're able to stay as long as they want and get to experience the site digitally, of course, in a fully immersive environment so that they can retain more information about the site. So the whole goal of this project was to see how VR and AR are used in a cultural heritage setting. And most of it, we saw that they don't really cater for research, but mostly for visitors' experience, to enhance visitors' experience. So we wanted to create and test VR and AR for conservation by combining it with existing imaging data from MCI Imaging Studio. To do that, what we did is we took a vase and we did a 3D reconstruction by using different imaging technique. The first one is modified visible, the second one is visible, and the last one is infrared imaging technique, so that we have 3 different models, and we imported these models into Unity 3D, which is a video game engine, and we created 3 VR apps, which are the desktop, Oculus Quest, and Google Cardboard, and then we created an AR app as well. So the key features for these apps is to integrate this different imaging technique in all the apps, but also to allow the user to navigate and rotate these objects in real time. But as well, we added hotspots and annotation to add complementary image and analytical data as well. And lastly, we added a note-taking ability, so in case if they see anything that's interesting, so they could take notes for it. This is a screenshot of the desktop app, and this is a non-immersive app. And the reason why we created this app is to allow more people that don't have access to an HMD to be able to use this app, or for people that have experienced cyber sickness. So I have a quick demo to show you how this works and display it. So this is the Unity environment. And once we start the app, everything that you see on the left are the different functionalities available for the user. And automatically the help button opens up to give you like sort of how this works. The buttons on the bottom are like input from the user, so they can move the objects in the world space, but they can also click on it and rotate the object by left clicking and dragging it based on wherever they click. So if I click on a specific point, that's where the object will rotate. So we'll skip just a little bit here so I can show you other features as well. So let's say if we move the object too fast, or we place it in a position we don't like, we can always reset it. We can also zoom in, zoom out by using the mouse scroll button. And we can zoom it as far as we want, or as close as we want, so we can look at the details. Another functionality that we added is to right click and hold it so that we can change the lighting source. And we'll see that in a second. We could also change between different imaging technique. The default imaging technique is modified visible, but we can click on different, like the visible imaging technique, but we can also rotate the object and decide to switch to IR, and we will continue where we left off in terms of rotation. And also, if we reset this and then take it back to the original position, you will see that there are annotation available in a numeral. So there's a #1 button. When we click on it, it will provide us with an image. Same if we click on the second one, it will give us like material used for painting and whatnot. So all these could be easily customized. We can add data, we can add videos, audio, to create these annotation buttons. And for IR, we also created different annotation buttons so that it allows users to have more understanding of the object. So I'll quickly fast forward again here. The last feature that we're gonna look at, it's note-taking. So you can see the note-taking button here on the bottom left corner. And then once we type our information and press enter, it will automatically save our notes. And then if we close and open the app, we will be able to access the same notes we've taken before. But let's say if we want to look at our notes without opening the app, we can click on print text and it will automatically be saved as a text file on our desktop, and we can access it and look at it without opening our apps. So this is our quick demo of the VR app, and then let's move on to the Oculus Quest one. So for the Oculus Quest here, I'll quickly use my laser pointer. The input has been slightly modified because the Oculus Quest comes equipped with 2 controllers, and they are sort of portrayed by these raycasts. So with the raycast, we can interact with the buttons to interact with the object. All the functionalities available on the desktop app are also available on the Quest, except for note-taking. So this is more like a high-end, app for people that have the Oculus Quest HMD. But for people that do not have an Oculus Quest but still want to have that full immersive experience, we created one for Google Cardboard. Since Google Cardboard doesn't come equipped with two controllers like in Oculus Quest, we created like this circle in the middle of the object. And whenever that hits the vase, it would change the texture to infrared. So the default texture is modified visible, but whenever the circle hits the vase, it becomes infrared. And whenever we look away, then it will revert back to modified vis. The last app that we created is the AR app. And for this one, what it does is it overlays the digital model over the physical one. And we have the same functionalities as the desktop app. We can go between different imaging techniques, such as the modified visible light, the visible light, and the infrared. And as like in the desktop app, we can also take notes and save our notes for future use. Unfortunately, we do not have the same functionality to save it as a text file and save it on our desktop. And since this was a remote fellowship, I did not have access to the vase. So what I did is I used the video game controller to as the target, as the physical target. So whenever the app detects the controller, it would automatically overlay the digital vase. So whenever I rotate the digital vase, the physical object, the digital object also rotates along. And let's say if we don't have a digital object, we can also use a QR code to generate this model. So to conclude, we see that there's a lot of promise for AR and VR for research and conservation, and they're highly customizable. We also see that we can easily integrate dynamic visualizations, different imaging technique, and note-taking in one single platform. And while we did a quick demo with other scientists at MCI, we noted that taking notes and collaboration are identified as key features, something that people are excited about. We also noted that it is easier for people to use these apps in a non-immersive desktop app or the AR app. A lot of people get motion sickness using HMD. So they are, and our limitation that we discovered is that data acquisition and the 3D reconstruction is time consuming and very difficult. And in addition, if we don't have good data, then the apps would not be as effective. Another problem we also noticed is about data storage and backward compatibility. So far, Unity has been is compatible with previous versions, but we're not sure how long this is going to be for how long. So there's definitely that question about how long can we use these apps and what happens when newer software are available. Another problem with this is there's a specialist is needed to build these apps. Someone that is familiar with Unity 3D or any other game engines and scripting as well in C# or C++. And also some people are reluctant to use like a head-mounted display or new technology. Therefore, they could be a little bit apprehensive about these. And of course, we mentioned the health issues that some people can experience cyber sickness as well. For our future work, we would like to incorporate these apps into future MCI projects, but we also would like to create and develop new features for these apps and collaborate with internal and external partners as well. And lastly, we would like to present and publish our research. So this concludes our presentation. Thank you so much.
Good afternoon. I'm Keats Webb. I'm an imaging scientist at the Smithsonian Museum Conservation Institute, and I worked with Yen for this project. Yen's not able to be here with us this afternoon for the Q&A, but I'm happy that he was able to record the presentation to share the research that he was working on. MCI is a Center for Specialized Technical Collection Research and Conservation for all of the Smithsonian museums and collections. We are the only Smithsonian resource for technical studies and scientific analysis for most of the Smithsonian's collection. And so we're able to offer unique analytical capabilities for Smithsonian researchers. So my routine work involves using a variety of imaging techniques to record and look at objects and materials to support research and conservation of Smithsonian collections. And so using a variety of imaging techniques, I had the questions of how VR and AR technologies could be integrated with the scientific and computational imaging at MCI, specifically for kind of research and conservation of Smithsonian collections, and whether this could increase the potential of analysis, interpretation, and resulting imagery. So VR and AR were something that I hadn't been able to devote much time to. So this fellowship was a great opportunity to have someone dive into the literature to see what was happening with VR and AR in terms of conservation and research applications, and also to do some developing and testing of pilot experiences and applications. So the focus of the project actually lent itself pretty well to being a remote fellowship during the pandemic. This was a year-long fellowship, as Yen had said. It was conducted entirely remotely. So I think that that provides kind of an illustration of reimagining of research and collaboration during the pandemic. This was an open project to better understand how these technologies can improve the analysis and interpretation, visualization, and delivery of imaging being conducted at MCI. And so while AR and VR may be useful in connecting kind of results from other or multiple analytical techniques that's conducted by scientists at MCI. I do want to note that I was able to attend the Voyager workshop yesterday, and I think there's some new features that are going to be introduced soon that will align with what we were trying to achieve with Yen's research and app development. So I think that that's kind of an exciting next step. So at this point, we can take some questions. So the first one is, could this work with other types of annotations, something like scientific analytical results, or even previous images from conservation treatments, or even historic photos? And so I think Yen touched on this with talking about the annotations, that could be audio, video, images. It could also be other analytical results. And I think that's kind of the benefit of thinking about how VR and AR could actually integrate that information in this kind of dynamic visualization process. So I think, yes, there can be different types of information incorporated in this. And that was also seen in kind of the platform that DPO has been developing with Voyager. So additional questions. What do you see as challenges for integrating this into kind of active projects or kind of the imaging that's taking place? So some of the challenges that I see have to do with the process of imaging the objects, because that can be a time-consuming process. And then also, so that's the kind of one side of it. And then on the other side of it, it's the specialized skills for creating the environment. So for this fellowship, we had a Yen who had those coding capabilities to be able to integrate the information, add the annotations. But I do think that Voyager, with those additional functionalities, is going to be able to help with reducing some of those barriers, at least on that back end of being able to input the information, add annotations, that won't require specialized skills. All right, so another question, can you discuss how the quality of the image capture in VR and AR differs from other traditional modes of capture? So this is a good question. I don't know that I will be able to speak to this entirely. So we are doing the capture the same that we would be doing kind of for our standard imaging projects. And so that is kind of high resolution photogrammetry capture, taking a lot of images around the object. And so it's not necessarily changing for being integrated with VR and AR. My understanding is that you might not be able to get kind of that highest resolution into those apps. And so that's a consideration. I think that with the AR applications, the size of the model, the quality of the model needs to be reduced quite a bit more because of the device that's running that. Next question, do you see these models as superseding the traditional photographic documentation workflows that exist in conservation, or rather as additional documentation? So I don't think that this would change the traditional photographic documentation. I think it's an added tool to look at the integration of those imaging techniques. And so one of the challenges that I found with working with a variety of different techniques is how do you overlay those in a way that the conservator and the researcher can look at those and interact with those. And so a lot of times with 2D imaging, I'm using something like Photoshop and doing kind of different layers and then turning those on and off, but that requires someone having Photoshop in order to interact with those and to look at the differences between the imaging techniques. So this was kind of exploring a way of how can we kind of lower the barrier for looking at those different imaging results, and is there a way that that integration actually adds insights to what we're learning about these objects or how these this information is coming together. Next question is, did you consider the use of AR, VR as a mechanism for doing things you can't in reality, i.e. breaking objects apart or comparing objects that are not co-located? So I think that that is something that is being done in other research groups, research labs. That was not something that we were necessarily taking into consideration as part of this project, but I think that that is a potential for these technologies. So yeah, looking at the different pieces, being able to pull those pieces together from different locations. I know that there has been some research in the past with even doing kind of virtual conservation treatments in order to put the pieces together and do that before any physical treatment is done. So I think that these technologies really do offer really interesting potentials for research and conservation. So another question is, how do you archive or record kind of the experience or findings and insights from this kind of integration of information or that dynamic visualization? And this is actually a question I still have. So how, if this is about kind of what you can learn by integrating the information, how can you record that in a way that can be saved long-term? And I don't know if there's any standards in terms of the archival quality of VR or AR experiences. And if anyone has any ideas about that or information about that, I would be very curious to hear about that. And I do think that this is a consideration, especially as part of a conservation or research workflow, being able to record how you got to certain information or what your interpretation of that information was in a way that other people can get to that or other people can understand the information required to get to that. So I think that those are the questions that we've received so far. Thank you so much for attending this information or this demo for this afternoon. If you do have any questions or follow-ups, please be in touch. This was a really interesting research project, and I do look forward to working with the folks at DPO to think about how Voyager can be a part of how we continue to think about this and continue this research. So thank you all. Have a wonderful afternoon.